not that good or not in the mood?
It's good, ma'am.
It's good. Have you guys gone through week 12 lectures? Have you guys gone through the week 12 lectures?
Not completely, ma'am.
Not completely. Okay, what about others?
Seen videos of week.
Sorry?
I haven't taken the lectures of week 12.
We have not seen the lectures of week 12. Okay. Okay, so how many of you have not even you have not watched week 12 lectures? Many of you? Not yet, not yet. Still doing. Okay. Okay, fine then. Let's go through week 12 then. Okay. Okay. Can you guys tell me what was there in week 11?
We studied about distributions, binomial distribution, hypergeometric distribution, and Poisson distribution.
The types of distributions.
Variable? Discrete random variable?
Yes,
Yes or
ma'am.
no? Okay. Now in week 12, we would be learning about the continuous distribution. Okay. So we had two types of random variable, right? We have a discrete random variable and we have a continuous random variable, correct? Now, what is a discrete random variable?
Which can
The
be
random
counted.
which can be counted, right? And continuous are basically my measurable quantity, okay, which cannot be counted, right? So that is my continuous random variable. Now in this continuous one we have different type of distributions. Okay, now before the distributions in discrete we used to calculate, we used to have PMF, correct? Yes or no? Do you guys know
Yes,
Yes,
what is
ma'am.
ma'am.
PMF? PMF is
Probability.
Probability mass function.
probability mass function. Okay, so this was for the discrete. Now for the continuous case, similarly, we have PDF, which is probability density function. Okay, so this is probability mass function and this is probability density function. Okay, now for if there is a mass, we will be that probability will be for the discrete case, and if it is showing density, it will be for the continuous case. Okay, now this probability mass function is generally denoted as probability of x equals to some value, right? And the probability density function is denoted as small fx. Fine. Okay, so this is my PDF and this is my PMF. Okay, so this is probability density function. So when whatever distribution that we are going to learn now, in that we will be having different PDF, different probability density function. Is it fine? Yes or
Yes,
no?
ma'am. Yes,
Yeah,
ma'am.
ma'am.
Okay. Now in PMF, we used to have some properties, right? Anyone remembers the properties? Properties of the PMF.
Sum of the PMF is equal to 1.
Yeah, sum of the probabilities was equal to 1. This was the first one, and the second one was
Combinatorial.
Probability will be positive
greater than equal
and
to 0, right? Similarly, in this case also, we will be having two properties. Okay, the first thing is the area. Okay, okay, before that, this probability density function, how will I draw this thing? This PDF is basically actually my curve. Okay, so this is my fx. Okay, So for a continuous distribution, we have a curve which is fx. This is my density curve. Okay. Now for this thing, so now we will do the properties here. The first property is the integration. That means the area under the curve, okay, is always equal to 1. This is my first property. Fine. Like we had the summation of all the probabilities equals to 1. Similarly, the integration means the area under the whole curve. Okay, that means this area. The area under the whole curve is equal to 1. Is this first property clear?
Yes, ma'am.
Yes, ma'am.
Yeah.
Yes.
Yes, ma'am.
Yeah. And the thing is, like the probability density function. What was the second property? Just let me give me a moment. Okay. And the area under the PDF between 2 points will always be between 0 and 1.
0 to 1.
This is my second property. Fine. Is this thing clear?
Okay, ma'am.
Okay. So this is the PDF and the PMF. This is the difference. Okay. In actual, PMF is basically what? We are actually like calculating the probabilities at that particular point. But in continuous random variable, we can't calculate a probability at that particular point. Okay. So in continuous, always remember that in a continuous distribution or a continuous random variable, the probability at a fixed point at a particular point is always 0. Okay. So that's why probability of x lying between a less than equal to x less than equal to b can be written as probability of a less than x less than b. Okay, because the probability at x equals to a, the probability that x equals to a will be 0 and probability x equals to will be 0 for a continuous distribution. Fine. Is this fine?
Yes,
Yeah,
ma'am.
ma'am.
We will get a straight line at that point. A
Because
single.
Yeah, because it's a continuous thing, right? It's a continuous distribution. So the like in the sense I don't have any fixed value. The values, the probabilities are in intervals. The my numbers are in intervals. I don't have a fixed particular distinct values I don't have, right? So that's why I have a continuous. So this will be like from 0 to 10, 10 to 20, 20 to 30, 40 like that. So in that I will be having many probabilities here, many probabilities here. So that's why we just take the area. Okay. So that's why at a particular point, my probability is 0. Fine. Now, in a continuous distribution, the first distribution that comes up is a uniform distribution. In the discrete case also, we had a uniform distribution, right?
Yes, ma'am.
Okay.
Yes,
Can
ma'am.
you tell me what is can you tell me what is a uniform distribution?
Tossing a fair coin.
Tossing a fair coin. Okay. In general, what is like any idea like definition type or something?
EMF will be equal for all possible
Okay.
values.
So basically,
The
this is my A and
probability for every x is equal.
If the probabilities are equally likely to take any of the value.
something. Okay. So uniform distribution is basically what? Um, from interval A and B, I have a fixed density, which is I'm just taking it as a constant term, which is k, right? So this is my density curve, right? So my fx is basically what k where my x is going from A to B, right? Now to find out this k value, how will I find out this k value? We know that
By
the
PDF.
area under the curve is always 1. So from A to B, my fx dx is equal to 1. Yes or no?
Yes, ma'am.
Okay. So my fx, in place of fx, I will just put the k value. So this is A to B, k into dx equals to 1. So k will, so this is x from A to B equals to 1. K B minus A equals to 1. K is equals to 1 upon B minus A. So this is my density. So that means this k value is this constant value is actually my 1 upon B minus A. So this value is actually 1 upon B minus A. So this is my uniform distribution. So what is a uniform distribution? In which the, if my x is following, I say that x is following a uniform distribution A to B, then the probability density function is given to be 1 upon B minus A, where my x is going from A to B. Is this thing clear? Uniform in the sense that from A to B, the density is uniform, is same. Correct? That is my uniform thing. So this is like a constant term. Now after that, I calculated what is this constant term, which is 1 upon B minus A. So this is actually my fx, right? The density curve, right? So fx is basically what? 1 upon B minus A, right? So if my x is following a uniform A comma B, then my density curve is given to be 1 upon B minus A. Is this thing clear?
Yes, ma'am.
Sure. Any doubts?
So, ma'am, from A to B, the probability, the PDF will be 1 upon B minus A for all values from 0 to no, from A to B.
Can you go once again?
From A to B,
Hmm.
the fx, which is PDF, right,
Hmm. Hmm.
that will be constant 1 upon
That
B
will be
minus
one
A.
maha constant. Correct.
Okay, ma'am.
Yeah. Okay. Okay. Let me see if any question is there. Just give me a moment. Okay. 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 Before that, now we have, this is my PDF, right? Now we have another term which is CDF. What is CDF? Anyone?
Cumulative distributed function.
Cumulative
Cumulative
density.
Yeah,
density
it is
function.
basically cumulative distribution function. So again, we are going to calculate the value of cumulative distribution function of a uniform distribution, right? So it is represented as fx. Okay. Now my x, for x less than a, it will be 0. Yes or no? See, if you see the figure here, less than 8, 0. Now at a,
Yes,
it
ma'am.
have a jump. Correct? Now, for x between A and B, it will be what? So let's suppose if my graph is like
1
this.
upon B minus A.
This is A, this is B. This is my 1 upon B minus A. So let's suppose my x is coming in between here, right? So now the probability that my x is like that my capital X is less than equal to small x will be equal to what? It will be, I will just integrate from A to X. Yes or no? Or if I just calculate the whole area, it will be what? From 0 to A, fx dx plus from A to X, fx dx. Correct?
Yes, ma'am.
See, this will be my figure. If you see here, this will be from 0 to A. Then from A, it will have a jump. Then it will go constant. Then again from B, it will go like 0. So this is my figure. Okay. This is my X. So if I have to calculate this thing, so what I will be taking from 0 to A, then A to X. Yes or no? So now this thing is actually what? 0 only, because if you see here, this value from 0 to A is actually 0. There is no value. So this is 0. So in short, I
Yes,
have
ma'am.
from A to X, fx dx, right? Now this is A to X, 1 upon B minus A dx. This will be 1 upon B minus A, x, A to X. This will be X minus A upon B minus A. So this is my probability that my X is less than X. So if I just put this value here, I will be having X minus A upon B minus A. Okay. And for X greater than equal to B will be 1. So this is my CDF of a uniform distribution. Is CDF clear to everyone?
Yes, ma'am.
Sure to everyone? Can I get a thumbs up
Can
or
you
anything?
repeat once?
Okay. See, what is fx? Fx is like a CDF, right? We like, I think we have learned how to calculate the CDF, correct? For a discrete distribution, how we used to do for x less than, I will be taking the whole area for x less than a. I will be taking x less than a, then from a to b, then b to like infinite, right? So this is my whole area, right? So my fx for x less than a will be 0, because this is 0 only, because I have a jump at a only, and before that it's 0, correct?
Yes, ma'am.
So this will be 0. Now from A to B, okay, if my x value is between this area, so I have supposed that this thing is my x. So I need to find out the probability that my x is less than small x, correct?
Yeah, ma'am.
Okay, so this will be what? I will be taking the area from 0 to A, then from A to x. Yes or no?
Okay, ma'am. So,
है ना? So
yeah,
this
yes,
thing
ma'am.
is actually 0 only. Okay, so we
Yes,
will
ma'am.
just be finding out this integrate. We will be integrating this value only.
Yes, ma'am.
Okay,
And this
A to
is,
X. So
yeah,
if you just solve this, you will get this thing. So we got that the probability, that is the fx for x taking values between A and B, is given by this distribution.
okay. Got it,
Fine,
ma'am. Yeah,
got
ma'am.
it? Okay. So this is like a simple thing. If they ask, let's suppose, if I give you an example, if I give you a question, um, give me a moment. Let's suppose if my x is following a uniform distribution between 2 and 5. Now you need to calculate the probability that x is less than equal to 4. So this is what? A CDF part? Yes or no?
Yes, ma'am.
And if they asked about the CDF, you just have to, you know the formula of CDF, which is x minus a
X
upon b
minus A
minus
upon
a.
B minus. Yeah, ma'am.
Huh. So just put the value in place of x, you just put the value of 4. So this will be
4,
4 minus, what is my a? This is my a and
2,
this is my b. So
B,
this
yeah,
will be
ma'am.
2 upon 5 minus 2, which is 2 upon
3.
3. So this is my probability that x is less than 4. That's it.
Okay,
Clear?
got it.
Got it? Now it's fine to everyone.
Ma'am, can you again explain the second property of PDF? I'm a little confused.
Which one?
The second property of PDF properties.
Here.
Yeah, area under the PDF between 2 points will always be between 0 and 1.
The area under this curve, right? This area will always be between 0, because it's like a probability only, right? And probability is always between 0 and 1, correct?
But in
So
the
my
first
area will also
property,
be
it is already written, na? The integration
this
of
whole area, the area, like we calculate the area of a rectangle and something, correct? The area, this whole area is equal to 1. But the PDF, the fx is always between 0 and 1.
Yeah, okay, got it.
Got it? Similarly, if you see here my fx, if you see the CDF also, it is between 0 and 1, not more than that, correct?
Yes, ma'am. Okay,
Because
got it.
fx or capital Fx, these are all probabilities, right? And the probabilities are always between 0 and 1. Fine? It's just a
Fine, ma'am.
simple property of a probability. That's it. Fine?
Yes, ma'am.
Okay. Can I proceed further? Is
Yes,
uniform
ma'am.
Yes,
distribution
ma'am.
clear? The CDF is clear to everyone?
Yes,
Yes,
ma'am.
ma'am.
Okay. Now we have a standard uniform distribution. What is a standard uniform distribution? Anyone? A standard uniform distribution is that distribution in which my A is 0, value of A, that is, this is A is actually my minimum value, correct? My minimum value is 0 and B is 1, that is my maximum value is 1. So that my PDF is coming out to be 1 when my X is between 0 and 1. So this is my standard uniform distribution. Okay? Now, the next thing
Ma'am,
is,
standard
uh,
uniform distribution and standard normal distribution, these are same or different?
no, that is different. That is for the normal distribution. This is uniform distribution. We are talking about uniform. That is a normal distribution. Both are different. Okay. But the concept main thing is the standard means whose expectation is 0 and whose variance is 1. That is my standard. Standard in the sense, you just standard means that my mean should be equal to 0 and my variance should be equal to 1. So then only I can say that my distribution is a standard distribution. This is the main thing, main definition for a standard. Okay. Now, the expectation of a uniform distribution. How will you calculate this? What is expectation? General formula of an expectation?
Expectation of x square minus.
E of x is equal to summation of x into p of x.
Yeah, yeah.
That is for the discrete, right? If we are talking about the continuous, we will be integrating it.
Yes,
Yes.
ma'am.
X into fx dx, and the limits will be from a to b. Yes or no?
Yes, ma'am.
Okay. So this will be
Yes, ma'am.
integration from a to b, x into 1 upon b minus a into dx. This will be 1 upon b minus a, x square by 2, a to b. This will be 1 upon b minus a, b square minus a square divided by 2. So if you see, this can be written as b plus a, b minus a divided by b minus a into 2. So this will get cancelled. So we are left out with b plus a by 2. So this is my expectation of a uniform distribution. Is it fine?
So it is mean
Yeah,
value.
Yes,
this
ma'am.
is my mean value. Okay. And similarly, you can calculate for the variance. How will you calculate the variance? Expectation of x square minus expectation of x whole square. So after first you will calculate this thing, then you will calculate this thing. You have already calculated, you just have to square this value. And after that, you will get this value, which is b minus a whole square divided by 12. This is my variance of a uniform distribution. Okay. Now, if you see here, my expectation is b plus a by 2 and variance is this. Now, if you find out the value for like a is 0 this. For this, expectation of x will be what? B plus a by 2. What is b? 1. A is 0 by 2. This will be, just a
1
second.
by
Should be 0. Distribution. Mm, 1 by 12. Okay. Okay. For the standard uniform, we just have to make sure that my A is 0 and B is 1 and my PDF is coming out to be 1. So this is my condition for a standard uniform. The thing that I told you for means is equal to 0 and variance equals to 1, that is for the uniform case, not for the uh, sorry, that is for the normal case and this is for the uniform. For uniform, you just have to remember that my minimum value should be 0 and my maximum value should be 1 and my PDF should be equal to 1. This is my condition for a standard uniform distribution. Okay, the thing that I told you for the mean 0 and standard deviation 1, it should be for the normal distribution. That's the condition for the normal. That's it. Okay. So this is all about the uniform distribution. Is uniform distribution clear to everyone?
Yes,
Yeah,
Yes,
ma'am.
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 Sure.
Yes, ma'am.
Okay. Okay, let
Ma'am,
me
in
just
these
find
type
one
of
question.
questions,
Sorry.
ma'am, in this type of questions, you wrote the formula, na? I was asking that in this type of questions, will we have to like integrate and then get the answers or directly apply the formula?
Um, okay, let's do one question. I'll just give you one question. Okay.
Okay, ma'am.
See, I have been given, I've been given that X is a uniform distribution with um, parameters minus 1 comma 3. That means my fx is given to be 0.25, where my x is going from minus 1 to 3 and 0 otherwise. Okay. Now the first question is you need to find out the CDF. What will be my capital Fx? Can you guys tell me that? Any idea? At least try it. See, what is the figure that we can draw? This is like 0, this is 1, and this is 3. Okay, let's suppose. And this is like 0.25.
1.25 upon 4.
Okay, sorry,
Ma'am, 1.25 upon 4.
1.25 upon 4. What is this? No, I need the whole PDF thing.
Okay, ma'am.
So less than minus 1 will be
Yeah,
0.
x less than minus 1 will be 0. Then from minus 1 to 3 will be.
That part we have to integrate.
That part you have to integrate. Can you guys integrate?
Ma'am, what was the function given?
Function is this.
Zero
Ma'am, I think
comma
1.
after what is
1.
Yeah,
What?
0.25 integration dx. So x we have to integrate and then minus 1 to 3 will be the limit. 4 into 0.25.
No, no, no. Okay. See, let's suppose. So my x is between minus 1 and 3, right? So let's suppose I'm taking x like here. Okay. So what I will be counting? I will be counting probability that my x is less than equal to small x, correct? Okay, so this will be what? From first, from 0 to -1 fx dx plus from -1 to x fx dx. Correct? Yes or no?
Yeah, ma'am.
Yes
Yeah,
or
ma'am.
no? Yes.
Yes.
Okay. Now this thing is 0 only because less than
Yeah,
-1 is
ma'am.
actually 0, right? Now we are left with from -1 to x fx dx. Now what is my fx? -1 to x 0.25
Right.
dx. So this will be 0.25 -1 to x. This will be 0.25 x plus 1. Yes or no?
Yes,
Yeah.
ma'am.
So this is my probability that my x is less than small x. So can I write it 0.25 x plus 1, and for x greater than equal to 3 will be 1. Yes or no?
Yes,
Yes,
ma'am.
ma'am.
Is the question clear to everyone? How to
Yes,
solve,
now.
how to find out the CDF?
Yes, ma'am.
Yeah, now
Sure?
clear.
No
Yes,
doubts,
ma'am.
right?
Yeah.
Repeat
Okay.
again,
Yes,
please.
Sorry?
no.
Can you repeat? Yeah.
Repeat. Okay, for this thing.
Ma'am, I had one
Yes,
question
ma'am.
here.
Yes, ma'am.
Hmm. Okay.
Ma'am, in this
Huh.
graph, whatever you did, you took x at between 0 and 3, right?
No, you can take here also. You can take here also anywhere.
But then, ma'am, you should have done like, say for example, I take x at the left side of 0. So it should be -1 to x, then from x to 0 and 0 to 3, right? From the left side if I integrate the
We are just
limits.
finding out till x, right?
We are creating a function, no, for
So it should be from
-1
-1
to
to
3.
x, right?
Huh.
Okay, okay. Okay, now understood. Yeah.
Okay. Okay, someone told me to repeat. Should I repeat?
Yes, ma'am.
Okay. See, this is my function. This is the PDF that have been given for the uniform distribution. So this is the figure of the uniform distribution. Now I need to find out the fx. Now, how do you find out the fx? First, you will calculate for the x value taking less than -1. Then from -1 to between -1 to 3, and from 3 greater than 3. Correct. This is how I write down the intervals of a PDF. Yes or no? Correct. Now, for
Yes, ma'am.
x values taking less than -1 is 0 only. Now, from
Got it.
-1 to 3, what I will be doing? So, x is between this interval. So, I will just take one value, one imaginary value that my x is here. So, if I need to find out this x, what I will be taking? I will be first I will be integrating from my from okay,
0 to -1.
this is minus infinite, not 0. Okay,
Mm.
1 minute. Okay, this is minus infinite. Now, from minus infinite to 1, this is fx dx. Then from -1 to x. So this is the two integration that I will be doing. Correct?
Yes, ma'am.
Okay. Now this thing is 0 only. Now
Mm.
I will be left out with this thing, this integration. Now after integrating it, I got this value. So this is for my x between -1 and 3. Correct? So that's my fx is coming out to be 0.25 multiplied by x plus 1, and for x greater than 3 you just it's 1 only. If you integrate it also you will get 1.
Thank you.
Okay, now
Thank
it's
you.
fine.
Yes, ma'am.
Okay, now next question is you need to calculate expectation of x. Can you calculate and tell me the answer?
A plus b by 2, right?
1.
Hmm.
And then it should be 1.
It should be 1. So expectation, the formula of expectation is b plus a by 2. My b is 3 and my a is minus 1. Okay, so I can write this as 3 minus 1 by 2. This is 2 by 2, which is 1. So my expectation is coming out to be 1. Fine. Now, what is my variance?
E of x square minus E of x whole square.
Why you're doing this? You can
1
just
by
use
3.
this formula, right? B minus a whole square divided by 12. Just put the values here. So this will be b minus a whole square divided by
1
12.
by 3.
So, sorry?
0.33.
Ma'am, 4 by 3.
1 by 3.
So this will be 3 plus 1 square, which will be 4 4 is 16 by 12.
4 by
8,
3, ma'am.
6, 4, and 3. This will be 4 by 3. So my variance is coming out to be 4 by 3. Or you can just put it in decimal also. Okay. So this is how you solve for a uniform distribution. Is uniform distribution clear?
Yes, ma'am.
Yeah, ma'am.
Okay. All clear? Uniform distribution. This was all about uniform. You just have to remember the formulas. The expectation, the variance, the PDF form. Okay. The PDF is 1 upon b minus a. The CDF is given to be x minus a upon b minus a. Expectation is given to be this and variance is given to be this. Okay. Now, next thing is we have exponential distribution. Okay. What is exponential distribution? This is also like a continuous distribution only. You can say that it is actually a distribution which is like used to model the waiting time until an event occurs. Okay. For example, like you can take an example like the time until a customer arrives at a store, right? So basically, what is the waiting time until an event occurs? So until a customer enters the store, what is the waiting time? So that for there we use the exponential distribution. Okay. So we say that my x is following an exponential distribution with parameter lambda. So here my lambda is my parameter. Okay, similarly for uniform distribution, I have two parameters, which is a comma b, right? So these are my two parameters of a uniform distribution. Similarly for the exponential distribution, we have one parameter, which is the lambda. So if x is following an exponential distribution with lambda as a parameter, the PDF is given to be lambda e raised to the power lambda x, where my x is greater than equal to 0. Okay, this is the distribution of an exponential distribution. Is this fine?
Is lambda representing the rate?
Sorry,
The lambda there
for some
represents
lambda, it's just a parameter.
okay.
Okay,
It represents the rate of customer with respect to time.
yeah, you can say that the intervals or the lambda exponential, yeah, you can say the like the rate or the average like the average value per unit time. That is my lambda. You can say that. Okay. Okay. Is this fine? This is like a rate parameter or the average value. Okay, so lambda is my
Okay.
rate value, or you can say the average value. Now for this also we can have the CDF, and how the CDF is calculated?
By integration.
Probability that my x is less than, let's suppose, for fx or like small x, right? This will be what? Integrating from 0 to x fx dx. This is how you calculate the CDF. Yes or
Yes,
no?
ma'am.
Okay. So if you calculate
Yes, ma'am.
this from 0 to x lambda e raised to the power minus lambda x dx, if you solve this thing, this will be what? This will be coming out to be 1 minus e raised to the power minus lambda x. This is my fx dx. Like you have to solve this thing by integration by parts. The formula. If you put the formula after solving all of that thing, you will get fx as 1 minus e raised to the power minus lambda x. So if anybody is asking, like, let's suppose my x is following an exponential distribution with parameter as 2, then what is the probability that x is less than equal to 1 or something? Then you will calculate it as 1 minus e raised to the power minus 2 into 1, which is 1 minus e raised to the power minus 2. After calculating this, you will get some value. So this is the formula of a CDF and this is the PDF. Okay, don't get confused with the CDF and PDF. The PDF is always written in small letter and the CDF is always written in capital letter. Okay, always remember this thing. Fine? Yes or no?
Yeah, ma'am.
Okay. Now,
Yeah.
similarly, for this, the expectation value is given out to be 1 upon lambda, and the variance of the exponential distribution is 1 upon lambda square. Okay. Is this fine? You just have to remember this thing, few things: the PDF, the CDF, and the expectation and variance. That's it. Is this fine?
Yes, ma'am.
Yeah, ma'am.
Okay. Okay,
Ye-
let's take one example. Hmm. Okay, there is one question. Okay, so the question is, we have been given the probability density function for an exponential distribution, which is fx equals to k e raised to the power minus 5x, x is greater than 0 and 0 otherwise. Okay, you have to calculate the value of variance of x. Can you guys calculate this thing? Can you guys calculate this thing?
Ma'am, what you have written that k e to the power minus 5x?
K e raised to the power minus 5x. Yes.
0.004.
How did you calculate this thing? Can you tell me?
I'm
How
using
did you?
the formula, I think,
The,
1 by
the
lambda
value of
square.
1 by lambda square. Okay.
Yeah,
So
ma'am.
just
lambda
I'm
putting the
equal
putting
to
value
5.
5. Yeah. 1 by 25 and then
1 upon lambda square. So you just put 1 upon 25. So this will be 1 upon 25 is basically 0.04. That's it. That's it.
Yeah, ma'am.
Okay. You just calculated in this way, right? Okay. This question, it's already written as exponential. Fine. Okay. Let's suppose that I have not said that it's an exponential distribution, only a PDF is given. Then how will you find out the value? It's not given that it's an exponential distribution. Then how will you
Then I
solve?
would have done e of x square minus e of x whole square.
No, this is some constant value, right? So first you will find out this k value, right? Yes or no? First, you
Yeah,
will
ma'am.
find out this k value. After finding out this k value, if you get that my fx is this k value is coming out to be 5. So my PDF will be written as 5 e raised to the power minus 5x. So this is in the form of lambda e raised to the power minus lambda x. So this is now an exponential distribution. Then you will put the formula of variance. Fine?
Okay, ma'am.
Yes. Okay. Now,
Ma'am, if k
mm,
was not 5, then what we would do?
then you
Can
will
you
just,
give an example?
huh? Sorry.
Can you illustrate with an example
Like what? For what?
for the
Ma'am, can you just
if
say
it
first
is not
that
mentioned
if
that it is an exponential.
So once again, can you repeat?
If it is not mentioned in the question
Huh.
that it
Hmm.
follows an exponential distribution,
Okay.
can you illustrate this one with an example?
See, I'm just taking this example only. Let's suppose I've just given the PDF here, which is fx k e raised to the power minus 5x, x is greater than equal to 0. We have to calculate the variance, correct? That's the only thing that I have been given in the question. I've not said anything that this is a continuous distribution. We have been given a continuous distribution function.
Mhm.
This is the PDF, and we have to calculate the variance. So the first thing, what you will do, you will find out this constant k value, right?
Yes.
How will you calculate this? You know that the area of the whole the fx is equal to 1. Area under the curve is equal to 1,
Yes.
right? That means my 0 to infinite fx dx is actually 1.
Yes, ma'am.
Okay, so if you just put the value here, 0 to infinite k e raised to the power minus 5x dx equals to 1. K will be a constant term, so this will be 0 to infinite e raised to the power minus 5x dx equals to 1. Now if you remember this thing, if you know this thing, integration of e raised to the power minus x dx will be equal to e raised to the power minus x. If it's like minus ax, so this will be e raised to the power minus ax upon minus a. So this is the integration for an e raised to the exponential thing. Okay, so if you just use this thing, so this will be k e raised to the power minus 5x upon minus 5, 0 to infinite. Correct?
Yes, ma'am.
Okay, so just put the values of x infinite and 0. You will get 1 upon, this will be infinite, this will be infinite, 0, this will be plus 1, 0, 1 by 5. Okay, so you will be left out with k into 1 by 5 equals to 1. So k will be 5. So you got the 5. So my PDF is coming out to be 5 e raised to the power 5x, where my x is greater than equal to 0 and 0 otherwise. So we see that this is like an exponential distribution. My limit is also greater than 0. Then the variance of x will be what? 1 upon lambda square, which is 1 upon 5 square, which is 1 by 25, 0.04. Now it's fine.
Ma'am, but
Yes.
you integrated and found out the value of k to match the condition, right? But ma'am, if say for example k was not 5, it was something else, then what we would have done?
Then you would have calculate how the variance is calculated, expectation of x square minus expectation of x whole square in that way.
Okay, ma'am. Got it,
Hmm.
ma'am.
Okay, let's take one another question. Let me see. Okay. Have you guys opened the portal? Like, can you guys open the portal activity question number 12.4? Question number 3. Have you guys opened it?
Just a second, ma'am.
Yeah.
Yeah, ma'am.
Okay. Everyone has opened it. I'm reading the question. Okay.
Yes, ma'am.
Okay. The waiting time in a hospital is said to follow an exponential distribution with an expected waiting time of 10 minutes. Let's suppose my X is the waiting time. Okay. So they are saying that my X is following an exponential distribution with some parameter lambda. Okay. Now, next thing is they're saying that the expected waiting time of 10 minutes. That means my expected value is 10 minutes. Yes or no? Correct?
Yeah, ma'am.
Okay. Now, what is the question they are asking? What is the probability that a person visiting a hospital has to wait for more than 15 minutes? That means I need to find out probability that my X is greater than 15, correct?
Yeah,
I
ma'am.
need to find out this value. This is the question. Now, how you will do it? Can you just tell me anything like what is coming in your mind or how should we proceed? Anything. You just try it once. Just try
From
it once and tell
expectation,
me.
we found lambda.
From the expectation. So if you see here, I don't have the parameter lambda. So with the help of expectation, I will first find out the parameter lambda. So expect what is the expected value of an exponential distribution?
1 upon lambda.
1 upon lambda. So this 1 upon lambda is coming out to be 10. So my lambda will be equal to 0.1. Okay.
Yes, ma'am.
Now probability x is greater than 15. Can I write it as 1 minus probability that x is less than equal to 15? Yes or no?
Yes,
Yes, ma'am.
ma'am. Yes, ma'am.
Okay. Now, if you remember this thing, the CDF, x is less than equal to some a value can be written as 1 minus e raised to the power minus lambda a. Do you remember this thing?
Yes, ma'am.
Right? So this is just in place of a, I have 15. So can I write it as 1 minus e raised to the power minus lambda is 0.1 into 15? Yes or no?
Yes, ma'am.
Everyone?
Yes, ma'am.
Yes?
Ma'am, I think
Okay.
I missed that one.
Sorry?
I missed that one.
Which one?
Px less than equals to equals to 1 minus to the power minus lambda.
You just then just remember this thing. Okay. Like if you just integrate it, right, you will get this thing. Just remember this thing. This is the CDF. Okay.
I get this, but why are we doing
Got
x
it.
or equal to 15? Why can't we just take zero point 0.1 into 15 and
Hmm?
why can't we just take e to the power of zero point 0.1 into 15? Why are we doing this step?
Which one?
Okay, all right. No, I got it.
Hmm. So this one will get cancelled. So I will be left out with this term only. So now you will find out this value. Can you tell me what is this value? E raised to the power minus 0.1 into 15.
Yes.
That was the formula you used for CDF, that 1 minus e to the power minus lambda x.
0.2231.
Yeah. So basically this is 0.22 approx. So it's
Is there
coming
any
between
other way we can calculate x greater than 50 without doing 1 minus?
without
Doing 1 minus p of x less than 15.
mm, so then you will calculate then you will integrate it right from 15 to infinite the fx dx. Then first you will find out the PDF, then you will integrate it, and then you will find the value. That way also you can do it. Okay.
Yes, ma'am.
So is this question clear?
Yes, ma'am.
Yeah,
So
ma'am.
this was all
Yes,
about
ma'am.
the exponential distribution. Okay. Now we have the most important, the normal distribution. Just give me a moment. Okay. Now, normal distribution. What is a normal distribution? We say that X is following a normal distribution with two parameters, mu, comma, sigma square, where mu is my mean and my sigma square is my variance. Okay. So these are the two parameters for a normal distribution, which are the mu and the sigma square. Okay. So we say that my X is following a normal distribution with mu comma. So if I have a mean, if I have a variance, then we say it's a following a normal distribution. Okay. And the PDF is given to be 1 upon under root 2 pi sigma e raised to the power minus 1 by 2 x minus mu whole square divided by sigma square. This is the PDF of a normal distribution. Okay, where my values of X is going from minus infinite to infinite. Okay, so we say that X is following a normal distribution with two parameters, mu and sigma square. And the PDF is given to be 1 upon under root 2 pi into sigma e raised to the power minus 1 by 2 x minus mu whole square divided by sigma square. And the graph is given to be like this is this this is my this is my fx. This is the graph of a normal distribution. Okay, so the graph of a normal distribution always looks like a bell curve. Okay, we call this curve as a bell curve, bell shape. Okay, and this middle part is actually my mu. Fine.
Yes, ma'am.
Yes. Okay. Now
Yes,
we
ma'am.
have some few things. Okay, so my mu is actually my mean, and my sigma square is actually my variance. Okay. Now, if I just keep my mu same, okay, this is some like a very important thing, like practical thing. If we have same mu and different value of sigma square, okay, that is my variability, right? So if I have different value of sigma square, then the graph will show like in the sense, let's suppose if I make a graph. Okay, I have like three values. Sigma equals to 0.5, sigma equals to 1, and sigma equals to 2. If I make this graph, Okay, before that, if that I have to tell you the height. Okay. Okay, before that, let's calculate the height. Okay, how do we calculate the height of the curve? Height of the curve is actually this, which one? This one?
The
Yes.
y coordinate.
Y coordinate, right? So we know my fx is what? 1 upon under root 2 pi sigma e raised to the power minus 1 by 2 sigma square x minus mu whole square. Now in place of x, I have the value mu. So in place of x, if I put the value of mu, I will be having 1 upon under root 2 pi sigma e raised to power. This will be 0. I will be just left out with 1 upon under root 2 pi. Yes?
Can you repeat that?
Sorry?
Can you repeat that?
See, I'm just calculating the height of the curve. Height of the curve is basically this part,
Yes, ma'am.
right? Now this thing is actually what? The value of mu.
Yes, ma'am.
So in place of x, I'm just putting the value of mu. If I put the value of mu, it will be what? 1 upon 2 sigma square 0 square.
Yes, ma'am.
So this will be what? E raised to the power 0 is 1. So I will be left out with 1 upon under root 2 pi sigma.
Got it.
So this is my PDF of like height of the curve, right? Now in this case, let's suppose my mu is same. So if I calculate, so let's suppose my mu is 2, okay? And my sigma is 0.5. If I calculate this, my height is coming out to be 0.798. Okay. Similarly, if I keep mu equals to 2 and if I change my value of sigma to like 1, okay, I will have a different height. Mu equals to 2, sigma equals to 2. Then I will have a different. So if I draw this graph here, okay, so let's suppose this is my 2. This is my mu equals to 2. So if I draw the graph, okay, so the first graph is I'm just drawing a rough diagram. Okay, just take it in a general case. Okay, so if you see here, if I keep the value of mu same and if I take the value of sigma different, that means my variance is different. So if my value of variance is getting larger and larger, like from 0.5 to 1 to 2, then my graph will go flatter and flatter. Okay, so the larger the value of sigma, the flatter is the curve. Fine. Just take it as consider it like this. See, sigma is 0.5 and sigma is 1. So my standard deviation, that means my variance is little bit large, right? Compared to the previous one. So if my variance is large, that means my spread will be more. Yes or no? There is no variability. Like, sorry, variability is highest, right? So I will have a, compared to this one, this graph, this will be a little more spreader. It will more spread, right? And if I increase the standard deviation to 2, it will again spread more than 1, the previous graph. So that is the same thing. If you increase the value of sigma, if you increase the variability, my curve will go like it will spread more and more. Fine.
Yeah,
Is
ma'am.
this thing clear? Yes or no?
Yes.
Sure?
Yeah, ma'am.
Okay. Now, it's the same thing. If you have different mu, okay, if you have same sigma, if you have the value of sigma same, and if you have different mu, the main thing is just the graph will move. Okay, one graph will be like this, then the other graph will be like this, and the third graph will be like this. If it's like a same mu, sorry, same sigma and the different mu. Okay, this is my mu1, this is my mu2, and this is my mu3. We are just shifting the graph. That's it. Okay. Now, the important thing for a normal distribution is it's symmetric about mean. In the sense, like I have a graph like this, right? So this is my mu. So the area this side and the area this side is equal. That means my probability that my x less than mu is equal to probability that my x is greater than mu. Okay. So this can be, this is like the half area, this is half area, which equals to 0.5. So this area is 0.5, this area is 0.5. So if you just add it, the probability x, the whole area will be equal to 1. Fine.
Okay.
Okay. Yes or no?
Yes.
Okay. Now, one more thing. This is my mu. Okay. Then we have mu minus sigma, mu plus sigma, mu minus 2 sigma. Okay. This is mu minus 3 sigma, and this is mu plus 3 sigma. Okay. So these are my areas. So these are my range. So this is my mu. And then we have mu minus sigma to mu plus sigma, mu minus 2 sigma to mu plus 2 sigma, and mu minus 3 sigma to mu plus 3 sigma. Okay. So this is like the approximation rule, in the sense that my area between mu minus sigma to mu plus sigma is 0.68. Like my 68% of the probability or the population will lie between mu minus sigma to mu plus sigma. Similarly, between mu minus 2 sigma to mu plus 2 sigma, it is 0.95, and mu minus 3 sigma to mu plus 3 sigma, it's like 0.997, right? So that's why if you see here, like after 3 sigma, it's like the probability is like 0.03, like 0%. That's why only till 3 sigma we take the conditions. Okay, we take the range. So the range is between mu minus 3 sigma to mu plus 3 sigma. Is this fine? Yes or
Yes.
no?
Okay.
Sure. So you just have to remember this thing. So what is the thing? The probability between mu minus sigma to mu plus sigma, it is 0.68. From mu minus 2 sigma to mu plus 2 sigma, it is 0.95. And from mu minus 3 sigma to mu plus 3 sigma, it's 0.997. You just have to remember this thing. Okay. So if I take an example, if you need to find out the probabilities. Okay. So like let's suppose this is 69. Then we have 75.5. Then we have 82. Then we have 88.5. This is like 62.5. Then we have 56. And then we have 49.5. I need the probability that my x is less than equal to 82. Can you find out this value? What is the area that we need to find out? This is the area that we need to find out. Yes or no?
Yes, ma'am.
Yes. Okay.
Yes.
Now this thing is actually what? If you see here, this whole area is equal to 1.
Hmm.
This whole area is equals to 1. So if I need to find out this area, basically what I will do, from this whole 1, I will just cancel the probability that x is greater than 82.
Yes, ma'am.
And we know that, okay, if you see here, my mu is equal to 69, correct? Yes or
69.
no?
Yes, ma'am. Yes, ma'am.
Huh.
Yes.
So what is my mu minus sigma? See, this is like mu minus sigma is according to the graph, it's given to be 62.5.
62.
Mu plus sigma is given to be 75.5. Mu minus 2 sigma is given to be 56. Mu plus 2 sigma is given to be 82. And mu minus 3 sigma is given to be 49.5. And mu plus 3 sigma is given to be 88.5. Okay, these are the values that they have given. Fine. Okay. Now, if you see here, this thing, this is my mu minus 2 sigma, mu plus 2 sigma, and this is mu plus 3 sigma. Okay. And we know that this area, okay, I just left out one point. If you, okay, so I told that the like symmetricity, right? The normal distribution, it follows symmetricity. So in the sense, from minus mu minus sigma to mu plus sigma, this is also symmetric about the mean. Okay. So this will be what? So this will be like 0.34 and 0.34. Similarly for mu minus 2 sigma 2. So this area will be symmetric and this area will be symmetric. Similarly for the mu minus 3 sigma, mu plus 3 sigma. Okay. So if you have this value, yes or no? You getting my point or no?
Yes.
Ma'am, can you repeat?
If I just make another graph, let me just
Ma'am, can you repeat?
0.97.
see, this is my mu. This is my mu minus sigma, and this is mu plus sigma. Okay. Now I told that this area is like 0.68. Okay. And one more thing is, I just told that it's follow symmetricity. So that means this area and this area will also be equal. So this is like 0.34 and this is like 0.34. Similarly, if I calculate the value of mu minus 2 sigma and mu plus 2 sigma, right? So this was like, this whole area was like 0.95, correct? So now this total area would be what?
0.95 divided by 2. 0.475.
So we will have this some area like 0.475
475.
and this will also be like 0.475. Similarly, I can have for mu minus 3 sigma and I can have mu plus 3 sigma. So this area I will be having some area and this will also be having some area. Okay. So in that way, if I have 0.35, okay. Now, if you see here, if I have this area is 0.35, correct? And this whole area is 0.475. So can I get this value,
Yes, sir.
which is 0.75, 0.34. 0.135, correct? Yes. 0.475 minus 0.34. 0.135.
Yes.
Okay. Similarly, can I have this value?
Yes, ma'am.
Can I get this value? This will be what? So this total area, this is like 0.999.
Mm.
This whole thing is like 0.997, right? So this half area would be what?
0.99, 0.495, I
Right?
think.
4985, correct?
Yes, ma'am.
Yes,
And this
ma'am.
will be the
49.
same thing, 0.4985. Okay. So if I need to find out this value, what I will be doing from this whole thing, if I just subtract, so that means 0.4985 minus 0.475. If I subtract this value, what is the value that I'm getting? 0.024. Yes. So
Yes, ma'am.
the area between 0 plus 2 sigma to 0.0 plus 3 sigma is coming out to be 0.024. Yes or no? Yes.
Yes, ma'am.
Yes,
Okay.
ma'am.
So in this figure, this is like, this is mu, this is the range between mu plus 2 sigma to mu plus 3 sigma. So from this whole thing, if I just subtract this thing, will I get this whole area?
Yes, ma'am.
Okay. So can I write it as 1 minus probability of x greater than 82?
Yes, ma'am.
And this will be 1 minus 0.024,
Mm.
right? So if
Yes,
you
ma'am.
find out this value is coming out to be
0.976.
0.976.
0.976.
So,
So this is how you use this thing. Okay. Should I repeat this thing or should I make the graph again? Should I do it again? Anything?
Ma'am, if you can just repeat it, no need to draw it again.
Acha.
got it, ma'am. Or we can directly add mu minus 3 sigma upon 2. Or mu minus 3 sigma under area, or mu plus 2 sigma.
Hmm? Sorry, I
And
couldn't get you.
we can, or another way to do this is we can directly add from mu to mu plus 2 sigma and mu to mu minus 3 sigma area.
No, we just have this value, right? This is my 82 and this is 88.5, right? I need to find out this whole thing, this whole area.
Mhm.
Yeah.
Yes, sir.
Yeah. So how can you find out that thing with 82 and 88.5? This is a continuous distribution, right? So you need to integrate it. You need to find out the density. Getting my point?
Mhm.
Hmm. Okay. So just remember this thing. The area between mu minus sigma to mu plus sigma, the probability is 0.68. Okay. Yes or no?
Yes, ma'am.
Okay. Then mu minus 2 sigma to mu plus 2 sigma, it's 0.95. And mu minus sigma to mu plus 3 sigma is 0.997. Okay. Now, between mu minus sigma, so this was also like symmetric, right? So the area between mu minus sigma to mu will be 0.34. Similarly, mu plus sigma to mu is 0.34. The area will be just divided into half. Similarly, mu minus 2 sigma to mu and mu to mu plus 2 sigma. The area will be equal and the area will be 0.475. Similarly, mu minus 3 sigma to mu and mu to mu plus 3 sigma. The area will be equal. This will be equal to 0.4985. Fine.
Ma'am, can you just say how that values came actually?
Which one?
Ma'am, the values of the graph.
The
That
6895.
No, ma'am, how you are
Huh.
dividing the graph and writing the probabilities.
I think that's universally applicable to all normal uniform distribution, normal uniform confidence. And it follows symmetricity, hence it is divided into two parts.
Um, See, it's symmetric, right? So the center point is mu. So the distance, like this is like the distance, like what is the distance from like one sigma, like one standard deviation from the mu. This is the two standard deviation from the mu. This is three standard deviation from the mu. So these are the distances that I'm calculating. And as this is like normal distribution and it is symmetric about mean. So this mu minus sigma, the distance between mu minus sigma and mu plus sigma will be equal. Fine. So that is how I calculated all the probabilities. It's fine.
Ma'am, so
Um,
which one we have to remember?
if you just remember this main thing, the other part you can just calculate it, right?
Okay, ma'am.
Okay. But in the exam, they won't be like, it won't be that difficult. There is one another method, okay, which is known as the standard normal distribution. Okay. Standard normal distribution is that distribution in which my mean is 0 and my sigma square is 1. So if my x is following a normal distribution with 0 comma 1, I say that my x is a standard normal distribution. Okay. And the standard normal distribution is always represented by a variable z. Fine.
Yeah, ma'am.
Okay. So this is my standard. Just remember that my standard is always a distribution whose mean is 0 and variance is 1. Okay. And it is always represented by z. So if I make, so this is the same thing. Same goes for this thing. So if I make a graph, okay, so this is my mean is, okay, and variance is 1. So this is like mu. So mu minus sigma. So in place of mu is 0 and sigma is 1. So this will be minus 1. Mu plus sigma would be what? 0 plus 1, which is 1. So this will be like 1 and this is minus 1. This will be minus 2. This will be 2. This will be minus 3. This will be 3. Okay. So the same case, same it goes for this. This area would be what? 0.68. Then this area would be what?
0.95,
0.95. And the other area would be what? 0.
0.9 something.
0.997. Okay.
Yes, ma'am.
So this is the general case. This is the standard case. Okay. Now, there are some properties for the standard case. Okay. Now, probability, if I have to calculate the probability, z is less than minus x. Okay. This will be equal to probability 1 minus z is less than x. How? See, z is less than minus x. If I just draw the graph, okay, this is my x, this is my minus x. So I need to calculate that my Z is less than, that is this area. Yes or no? Z is less than minus X. This is my Z. So is Z less than minus X this area? Yes or no?
Yes, ma'am.
Okay. So now if you
Yes, ma'am.
remember normal, it's symmetric, right? So the area, this thing is equal to the area this side.
Yes, ma'am.
So can I write probability of Z less than minus X as probability of Z greater than X?
Yeah, ma'am.
Now
Yes.
probability of Z greater than X can be written as 1 minus probability of Z less than X.
Yeah.
So that's why
Yeah.
the probability of Z less than minus X is written as 1 minus probability of Z less than X. Fine.
Yes, ma'am.
Okay. Then the second property is probability that my Z going from Z A to B is given as probability of Z less than B minus probability of Z less than A. Right? So if I just make a graph, okay, let's suppose this is my A and this is my B. If I need to find out this area, what I will do? I will just subtract the whole this from this area, the whole area minus the
Minus area before A
this
and
area.
area after B.
So that's why this can be written as probability of Z less than B minus probability of
Z less than A.
Z less than A. Is this fine
Yes.
to everyone? Then we have the third
Yeah, ma'am.
probability. Probability of mod of Z greater than A is equal to 2 into 1 minus probability of Z less than A. Okay. So if I just write this, so probability of mod of Z greater than A can be written as probability that my Z is greater than A plus probability that my Z is less than minus A. Yes or no?
Yes, ma'am.
Yeah.
Yes. Okay. Now, this probability of Z less than minus A can be written as Z greater than A with the help of symmetricity.
Yes, ma'am.
So can I write it as 2 into probability of Z greater than A?
Hmm.
Okay. Now, this probability of Z greater than A can be written as 1 minus probability of Z less than A.
Yes, ma'am.
Huh? Okay.
Yes,
Give me a moment. Give me a moment. Okay. So this is the probability that my mod of Z is greater than A. This is the formula. Okay. So you just have to remember these formulas. Okay. Probability of Z less than minus X is written as 1 minus probability of Z less than X. Probability of Z between A to B is given to be great less than B minus probability of Z less than A. Then probability of mod of Z greater than is given to be like this. Okay. Now, the next important thing is, if I need to find out, for example, if I need to find out the probability that my Z is less than some value, like let's suppose is less than 2, how will you calculate this? You will calculate with the help of standard normal table, which is given like this. This is my standard normal table. Can you all see this table?
ma'am.
Yeah, ma'am.
Yes. Yes. So this is my
Yes,
standard
ma'am.
normal table. So if I'm saying that my probability that Z is less than 2, in the sense, okay, so if you see this graph, this is actually representing probability that my Z is less than small z. Yes or no?
Yes, ma'am.
Okay. So if I'm saying in
Yes,
place of
ma'am.
Z, I'm just putting the value of 2. So that means I need in place of Z that the value of 2. So if you see here, this is Z. Okay. So now in this thing, if you just check for the value, this is Z equals to 2.
Yes, ma'am.
2.0 is equals to 2 only, right? So you will check this
Yeah,
value
ma'am.
2.0. And if you see the upper part, which is 0.1, 0.0010, 0.01, right? So 2 point, this 2 can be written as 2.00. It will be
Yeah, ma'am.
same only, right? So you will have only this thing, which is 0.9772. So the probability that my z is less than 2 is equal to 0.9772. Fine. Now, if I need to calculate the probability that my z is less than 1.11, how will you see it? You will first see for the z. Z is like my z value is 1.11. I can write it as 1.1
661.
plus 0.1, correct?
Yes, ma'am.
Right? So
Yes,
first
ma'am.
I will find out this value. This is my z, 1.1. Okay. Then I need to calculate 0.01. So I will look this value, which is 0.8665. So this value is 0.8665. Got the point? How to
Yes, ma'am.
find a value from a z table?
Yes, ma'am.
Okay. Can you
This
tell me the
table,
sorry?
this table is only applicable to standard normal distribution.
Standard normal distribution. Yeah.
Okay. Okay.
Okay. So this thing is,
Ma'am, if
so
it is
can,
less than, ma'am, if it is less than, you write that particular value, right?
if it is less than,
Like less than 1.11, right? So you,
ha ha
for the
ha,
1.1 part, you wrote that value,
ha,
0.01 under that column.
ha.
Okay, ma'am.
So can you tell me probability z is less than 2.55? Can you tell me this value?
2.9945.
0.9946.
Sorry?
Ma'am,
0.9946.
0.9946 from the table.
0.9946.
9946, which is this value, correct? So we will be looking
Yeah, ma'am.
2.5, then 0.05. Fine. So you got to know
Yes,
how
ma'am.
to find out the value from a Z table.
Yeah, ma'am.
But
Yeah, ma'am.
you have to first, before checking this table, you have to check what value it's given. What is this value? Like what are the value that they are taking? Okay. Just remember
Yeah,
that.
ma'am.
Okay. Now, now comes to compute the probabilities. So if you have been given, let's suppose, so there is one more step. If you want to calculate the probabilities for a normal distribution, the first step is you have to convert it into a normal standard normal distribution. Because if you see the table, like if you like in general, we have only the standard table. Standard normal table is always given. Okay, that is the only thing. So the first thing, if we need to calculate the probability that x is less than 1 or something, if my x is following a normal distribution with 0 comma 1, or okay, let's take some mu comma sigma square as the mean. Okay, and we need to calculate the probabilities x is less than or some value a. Then the first step is you have to convert it into a standard normal variate. Why? Because only a standard normal table is given to us. So first you need to convert this into a standard normal variate, and then you need to calculate the probability. So how will you do that? So the if you have to convert this x to a standard normal variate, you will just might subtract this x with its mu and dividing it by the standard deviation. This will convert into a standard normal variate. Got the point?
Yeah, ma'am.
Yes.
What is the logic behind this?
See, the logic behind is this: if you just if like in general, like in practical, we have only a table for a standard normal distribution. We have been only given the z table. So if we have to calculate any probability for a normal distribution, we first have to convert it into a z. That means a standard normal variate. Then only we can calculate the probabilities with the help of the table. Got the point? Yes or no?
Yes, ma'am. Yes.
Okay, just to
Ma'am,
make,
but
see,
why do we need to convert this? Can you just tell that one?
I was asking why we have subtracted mu or divided by sigma.
Okay,
What's
that
the
thing.
logic of that?
Logic is, see, we are converting into a standard normal variate, right? And what is the
Yeah.
condition for a standard normal variate? My mean should be mu 0 and my sigma should be 1, correct?
Yes, ma'am.
So if I take the expectation of x minus mu upon sigma, this is coming out to be expectation of x minus mu upon sigma. This will
Oh,
be mu minus mu upon sigma. This is coming out to be 0. And similarly, if I calculate the variance of x minus mu upon sigma, this will be what? Variance of x divided by sigma square, because mu is a constant term. So we
mhm.
don't subtract it, right? So this will be sigma square upon sigma square. This will be 1. So variance is coming out to be 1. So that's why x minus mu upon sigma is the, like, this way only we can convert a no, variable into a standard normal variable.
Got it, ma'am. Thank you.
Got it? Yeah.
Yes, ma'am. Thank you.
So, ma'am, will
So,
this be
huh,
mentioned in the question that we have to convert this into standard normal variable and then solve the question?
no,
So we
you
have to
will be,
understand.
you have to understand. See, the main thing is you will be given, like, you will be given this value. F z of 0.25 is equals to some value. So this is the z value. So first you need to, so let's suppose my x is less than some a. So this is the x, right? So first you need to convert into a probability of z is less than a. Then you will find out the value. Got the point?
Yeah, ma'am.
Because the no, the table that we just looked, it's like a z table, right? This is the z table. Yes or no?
Yeah, ma'am.
Right? So first we need to convert this. So everything that we did, like this is z is less than 2, let z is less than 1.11, z is less than 2.55. We are not talking about probability of x less than 2.55. We are talking about z less than, that is a standard normal variate. So first you need to convert this x into a standard normal variate, and then you need to find the value from the table. Got the point?
Yeah, ma'am.
Okay. So now
Ma'am, can you just repeat?
what?
Ma'am, the above part, can you just repeat once?
The above part. See,
Yes, ma'am.
the main thing is, if the the thing is, x is given to be a normal distribution with mu comma sigma square. You need, if you need to find out probability that x is less than a, then the first step is you have to convert this into a standard normal variate. How? Just uh, just subtract this variable x with mu and dividing it by the sigma. So this will be converted into a standard normal variate. Then you will have the probabilities like z is less than some a minus mu upon sigma. So then you will calculate from the you will look at the table, like this value will be somewhat like 0.11 or 1.11 or 2.56 or something kind of like that. So this probability of z less than 2.56, then you will look at the table and then you will find out this value. Okay, so this is the process to find out the probability for a normal distribution. Got the point?
Yes, ma'am.
Okay,
Yes, ma'am.
to everyone.
Yes, ma'am.
Okay, so the thing is, if I need to convert this into a standard normal variate, so I have to convert this into z. So this will be what? X minus mu upon sigma. If I'm doing subtraction and division this side, I will be doing the subtraction and division this side also. Yes or no?
Yes, ma'am.
Okay, so this is probability of z less than a minus mu upon sigma. Then you will have some value, and then like from the table, you will calculate this value. Okay, let's do one example. Then it will be more clear to you. Um, Give me a moment. Okay, the question is, you need that x is a normal distribution with mean 5 and with standard deviation is given to be 2. That is, variance is given to be 4. You need to calculate probability of x is greater than 8. Okay, so what you will do? First step is converting this into a standard normal variate. So this will be what? X minus mu upon sigma greater than 8 minus mu upon sigma. Yes or no?
Yes, ma'am.
Yes,
Okay,
ma'am.
now this can be x minus mu upon sigma is z only, greater than 8
Yes,
minus
ma'am.
mu is 5 divided by sigma is 2. Okay, So this will be what? Probability that Z is greater than 3 by 2.
Yes, ma'am.
This will be probability of Z greater than 1.5,
1.
right?
Ma'am. Yes, ma'am.
Huh? Okay. Now can I write Z is greater than? So if you remember, acha, that was mine. Okay. So Z greater than 1.5 can be written as 1 minus probability of Z less than 1.5.
Yes, ma'am.
Okay. Now if you see in the table, what is probability of Z less than 1.5?
0.9332.
0.5596.
What?
0.5596.
0.9332.
Ma'am, 0.9332.
Oh, sorry.
Yes, ma'am. 0.9332.
0.9332. Okay. So this is my value. So if I just put the value here, so this will be 1 minus 0.9332, and this is coming out to be
0.0668.
0.66.
0668.
Okay, so this is the probability that my x is greater than 8. Is the example clear
Yes, ma'am.
to everyone? Okay. Now, similarly,
Clear, ma'am.
can you calculate probability x is greater than 5? Can you tell me this value?
X less than 5 or greater than 5?
Less than 5.
Okay.
If you want to see the table, I can show the table as well.
Ma'am, can you just show the value of sigma and nu?
Hmm.
Ma'am, 0 we get.
What?
Yeah, ma'am, show the table now.
It's 1 by 2,
Ma'am,
ma'am.
answer should be 0.5000.
Yeah, it will
Yes,
be
ma'am.
0.5.
0.
So 0.5, right? It's just simple, right? So if you see here, like logically, you see that this is my mu, and we are just talking about the area less than 5. So if you remember this thing, this is my graph and this is 5. So area less than 5 is actually 0.5 only, right? Yes? Yes or no?
Ma'am.
Yeah, ma'am.
Huh? Just simple is like that. Okay. Now can you calculate probability of mod of x minus 3 greater than 1?
Ma'am, can you show the table?
Hmm.
Ma'am, 3.83.
3.83. Okay, what about others?
Ma'am, 1.1747.
Different answers are coming. What, any other answers?
Ma'am, I have used the same value of sigma and nu that you gave above.
Okay, that's fine. Has anyone
Yes, ma'am.
solved? Has anyone solved? Only two answers I got. What about others?
Can you show the table again?
How did you guys calculated this value?
Ma'am, I used that 0.5 method only I used.
Ma'am, you said that one for the mod function x minus 3 is greater than 1 and x minus 3 is less than minus 1. Then I solved for x and then I used that formula x minus nu by sigma and then put the value of nu and sigma and got it.
This okay. If I solve it like this, so this will be probability of I can write this as 1 minus probability of mod of x minus 3 less than 1, right? Now this can be written as, this will be a long one. So now I will be converting this into a mod z, right? Oh, sorry. This can be written as minus 1 x minus 3 to plus 1. Now this will be 1 minus probability of minus 1 plus 3, 1 plus 3. Okay. So this will be 1 minus probability of 2 to 4. Okay. Then I will be converting this into a normal distribution. So this will be 2 minus 5 by 2 less than z less than 4 minus 5 by 2. So this will be 1 minus 5 minus 3 by 2, 1 by 2. Okay. Minus 1 by 2. So this will be 1 minus p minus 1.5 to minus 0.5. Now this thing is actually can be written as 1 minus probability of z less than minus 0.5 minus probability of z less than minus 1.5. Okay, then you will calculate this thing. Then you will take this value, then you will have this value, and you will calculate it. This is how you will calculate this. This is how you solve this question, this one.
Ma'am, just one thing. You did one
Hmm.
step before you when you were explaining the formulas. Ma'am, you said na, that P of mod z greater than or less than whatever the value is. We first split the mod function that P of z greater than 1 plus P of z less than minus 1. So doing the same thing and solving it, I got different answer. Like yeah, ma'am. Here you have like said na P of x greater than a plus P of z less than minus a. I did the same thing because here is x
So
minus
this
3.
can be, so you are saying this will be written as probability of x greater than, if this is 1. So this will be
No, ma'am. X minus 3 greater than 1
x minus 3 greater than 1 plus probability
plus
of x minus 3 less than
minus
1.
1.
Correct. Minus 1. So this
Yeah.
is actually what? X is greater than 4
4.
plus
Yeah.
x is less than
Plus
minus
2.
1.
Minus 2. No, ma'am.
Minus
Plus 2.
plus 2.
Yeah, ma'am.
Then the same thing if we do it like this. So
And
this
then,
is
ma'am,
not.
P of x greater than 4, I write it 1 minus P of x less than 4.
So this is this, if I just convert this thing, z less than minus 3 by, so this is 1 minus probability of z less than 1 by 2 plus probability of z less than minus 3 by 2.
Ma'am, minus half. You have not given the minus.
No, no. I've just converted this into a, this will be, this can be written as z is less than 1 by 2 also, right?
Oh, because of symmetricity. Acha, acha.
Hmm.
Got it.
Okay. So this
Hmm.
can be written as this thing. Then you will calculate this value and you will calculate this value and add both of these values.
Oh,
Like
okay,
that,
okay.
you can also solve it.
Ma'am, actually,
Okay.
I made calculation error, I think. That's why I got the wrong
Hmm.
answer.
Okay. So this way, so
Okay.
there are two methods. You can just do it in this way also, and you can do it in this way also. Any method. Okay.
Got
So
it,
this
ma'am.
is how. So this is the general thing. I just gave you the general idea how to solve like a like the normal distribution question. Okay. Is this thing clear? Is week 12 clear? Like you
Yeah,
got
ma'am.
few idea, like the overall idea, what is it about?
Yeah, ma'am.
Yes, ma'am.
Okay. Okay then. So yeah, that's it. So that was all in week 12. You just go through the lectures. Okay. Once again, try to do the questions, try to do the activity questions. You will get the idea more, like better idea. Okay.
Okay, ma'am.
Okay. Okay then. Bye everyone. Have a
Bye,
great night.
ma'am. Good night,
Bye.
ma'am.
Good night.
Thank you, ma'am.
Okay. Yeah. Bye everyone.